Hello students, welcome to my channel. In this class, I am going to teach you FERMAT'S factorization method. I will give an example to explain this method. After that, I will prove FERMAT'S little theorem. So let us proceed for the topic. Now FERMAT'S factorization method. This method says if n is a positive integer and if it can be expressed as the difference between squares of two integers like x square minus y square, we can write is equal to x plus y into x minus y. Then we can say n is factorized as FERMAT'S factorization method. So here n is equal to x square minus y square. N is a odd positive integer. X and y are two integers. Now one example I will take to explain this method. Use FERMAT'S method to factor 2, 3, 4, 4, 9. This is the number we have to factor it 2, 3, 4, 4, 9 using FERMAT'S factorization method. So let us proceed to solve this. Let us proceed for the solution. We have 2, 3, 4, 0, 9 less than 2, 3, 4, 4, 9 less than 2, 3, 7, 1, 6. We have taken this is square of 153. This is square of 154. So this number lies between squares of two numbers. So what then we have to do? Let us consider k square minus 2, 3, 4, 4, 9. Taking k is equal to 154 or greater than that. When we will take k is equal to 154, then we can write 154 square minus 2, 3, 4, 4, 9 is equal to 2, 3, 7, 1, 6 minus 2, 3, 4, 4, 9 is equal to 2. Then 155 square minus 2, 3, 4, 4, 9. This is 2, 4, 0, 2, 5 minus 2, 3, 4, 4, 9 which is equal to 576 is equal to 24 square. So what actually we get? This implies minus 2, 3, 4, 4, 9 is equal to 24 square minus 155 square. This implies 2, 3, 4, 4, 9 is equal to 155 square minus 24 square, which is equal to 155 plus 24 into 155 minus 24. So this is equals to, after addition it will be 9, 7, 1, 1, 7, 9. And after subtraction it gives us into 1, 3, 1. So we get 2, 3, 4, 4, 9 product of two numbers 179 into 131 which is a factor using FERMAT'S method. Hence 2, 3, 4, 4, 9 is equal to, we can write 2, 3, 4, 4, 9 is equal to 179 into 131. That is 179 and 131 are the required factors. With this, the example is now solved. Let us proceed to prove Fermat's little theorem. Now, let us prove Fermat's little theorem. It states that if P is a prime and a greatest common divisor between a P is 1, then a to the power P minus 1 congruent to 1 mod P. That is, a to the power P minus 1 minus 1 is divisible by P, that we have to prove. Now prove. Let us consider x1, x2 to the power P is equal to x1 to the power P plus P combination 1, x1 to the power P minus 1, x2, P combination 2, x1 to the power P minus 2, x2 square plus dot plus PCP minus 1, x1, x2 to the power P minus 1, x2 to the power P. So this is the binomial expansion of x1 plus x2. This can be written as x1 to the power P, x2 to the power P plus terms divisible by so this can be written as x1 to the power P, x2 to the power P terms divisible by P. So this congruents to x1 to the power P, x2 to the power P mod P. We can write like this. So this we take equation 1. x1 plus x2 plus x3 plus xa to the power P. x1 to the power P, x2 to the power P, 3 to the power P plus plus xa to the power P mod P. This is equation 2. So, in this way continuing, we can write the above expression, equation 1, as a equation 2. Then, putting x1 is equal to x2 is equal to x3 is equal to is equal to xa is equal to 1 in equation 2, we get. So putting x1 is equal to x2 is equal to x3 is equal to xa is equal to 1 in equation 2, we get 1 plus 1 plus 1 plus 1 to the power P. Here it is a times is equal to 1 plus 1 plus 1 plus 1 up to a times mod P. So this gives us a to the power P congruence to A mod P. So this is our equation 3. So expression 3. Given AP is equal to 1. So we have A to the power P minus 1 congruence to 1 mod P. So A to the power P minus 1 congruence to 1 mod P. That is A to the power P minus 1 minus 1 is divisible by P. Proved. So the theorem is now proved. Let us solve an example basing on this theorem. Question is prove that A to the power 30 minus 1 is divisible by 31. We know from Fermat's little theorem that A to the power P minus 1 congruence to 1 mod P, where P is a prime and greatest common divisor between a P is equal to 1. Here given 8 to the power 30 minus 1. So this can be written as 8 to the power 31 minus 1 minus 1. Now 8 to the power 31 minus 1 congruence to 1 mod 31. Here 31 is a prime and a 31 greatest common divisor is 1. So this implies 8 to the power 30 congruence to 1 mod 31 implies 8 to the power 30 minus 1 is divisible by 31 using Fermat's little theorem. Proved. Now the example is solved. The topic for today's class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.